Okay, sir.
Okay, Bismillah Rahman Rahim. Let's start with today's class, which is in which we will discuss about 3D commands, which we have started in the previous class. We started with the 3D basics of 3D modeling. Then we talk about the extrude command and how do we convert a 2D cross section into 3D. We also talk about how to draw a basic 3D models like box, wedge, cone, sphere, etc. In today's class, we will talk about some more advanced command of 3D, which are basically sweep command, loft command, revolve command. How do we convert a particular cross section into a 3D model? So we started with the extrude command, in which we just converted a cross section into a solid model, a 2D cross section into a solid model. And that conversion was uniform, which means when you are converting a particular cross section, so that cross section will uniform throughout the length of the path or toward the length of the extrusion. But sometimes we need to convert a particular cross section non-uniform. I mean that if let's say you want to convert, you want to make a cylinder which start diameter is half of the end diameter, so that cannot be done using the extrude commands. For it, we use normally sweep command. Uh, by sweep command, we mean we normally converting a cross section into a path, which is just like a sweep extrusion along a path, but we have more options compared to the extrusion command. So let me let me draw a simple circle over here, and you should keep in mind that while drawing the path for the extrusion or for sweep, we have to draw the path in other plane. As you see that I have drawn the rectangle, the circle in the top plane. Now I'm changing the view from top to right plane. Why? Because the plane and the object or the cross section must not be coplanar, must not be in a simple plane. So let me draw a spline over here. Let's say this is my path along which I want to convert this object. Okay. So if we change the cross section, the view into isometric view, you will be able to see it. That's my object. Okay. Sorry. Okay. Let me move this object near to this one so that it may clear to me. You can see you can see that the object is drawn in one plane and this path is drawn in another one, just like we did in the uh, extrusion along a path. But I told you that it is just like extrusion along a path, but it has some more options. Let's see what are the options over there. If I want to convert this cross section into this path, and it will be done with the sweep command. So the shortcut key for sweep is SWEEP sweep. It is asking me select a mood. We will talk about a mood. Let me talk about it. MO is for the mood. So do you want to convert this object as a solid or as a surface? So we normally want a solid object. We want to convert object as a solid object, so we keep it solid. Now it is asking me select object to sweep. So if I select the object, okay, we'll press enter. Then it will ask me base point, circle, twist, alignment, etc. So if I just select the path without selecting any option from here, it will be converted just like a extrusion along a path. And you will see the start diameter and the end diameter are similar because we have not changed any feature of this. So the simple The simple sweep is just like extrusion along a path. Okay, but if we give a scale to start and the end diameter, so the end diameter will be greater or smaller at a scale factor to the initial one. Let's say my start diameter is 1 unit, and if I give 1.5 for the end diameter, so the end diameter will be 1.5 meter. If I convert it with the scale factor of 1, or if the scale factor is 2, so the one diameter start diameter will be 1 and the end diameter will be 2. So let me do it again. Let me take copy of this so that we may take some more options over here. Okay, so let me convert this one with a simple sweep. Select object that you want to sweep. Okay, select path. Okay, it is converted with a simple sweep, which is just like extrusion along a path. But if I select sweep, select object, okay, and before selecting the path, if I select scale, let's see, it is 1.5. If I convert it, now you can see I have given a scale factor of 1.5, but it means that I'm telling the CAD that okay, extrude this object, which is a circle, along this path, but the end diameter of this object will be, this sweep will be twice of, yeah, 1.5 times of the this one. So it has increased the diameter. Let's say it is 1 meter, so this will be 1.5. It is 2, so if it is 2, so it will be converted as a 1.5 means 3 diameter. So it will be zero point 0.5 greater than this one. It is multiplied with the scale factor. Okay, so it, you can see this sweep can be achieved using a simple extrusion, but this cannot be achieved using a simple extrusion because we have given a scale factor of different value. So this is the advantage of using a sweep command, that we can change the diameter of the start. We can increase or decrease the end diameter according to our need, according to the scale factor. Let me do it this one again. Sweep, select the object. Okay, then it is asking me, before selecting the object, I will select scale, and let's say this scale is zero point 0.5 and select the object. Now you will see the end diameter will be half of this one because we have given a scale factor of 5. So we are reducing the diameter of the end cross section. And you can see again that these things cannot be done using the extrude, simple extrude command. There is another simple command over here where we can make align this cross section to this uh, path, which means that over here this will be considered as perpendicular or as it is where it was. Matlab, I mean that if this, the angle between these two can be adjusted by alignment. When you make it align, so this will be more perpendicular, it will be exactly perpendicular to this one. Okay, let me do it. Sweep, select object, and let's say align. So sweep object perpendicular apart before sweep. Yes. Okay. Yes. Now you will see that it is making perpendicular this object to the path. This is what it is doing. You can see over here that the object is perpendicular to the path. This is basically a path. This is the guidelines which are sweeping this object. So this basically we are making the object perpendicular to the path. Okay, so this is the difference. There is another option over here with the help of which we can give a twist. We can get a twisted object over here, which can be more visible using a rectangular object as compared to the circular. So let me draw a small rectangle over here. Okay, a box. Now I'm changing the view to this one again. So let's see, I want to convert. Let me take a copy of this object. Okay. It is not necessary these objects to be near to each other. This can be at anywhere, but you just need the objects not in the same plane. Let me convert this object into a sweep path with a twisted one. So you will see what is the what the twist mean. Select the object, okay. Before selecting the path, I'm selecting the twist. See, see, and the angle is, let's say, 90 degree. Okay, select the path. You will see over here the object is being rotated. You can see the twist. It is a twist is applied, which means that this corresponding point is rotated at 90 degree to the next corresponding point. Let's have to have faces over here, and now you want to convert it at a twisted object. So you are just rotating the one plane to the other direction in a clockwise, anti-clockwise direction at a particular angle, and then you are joining the corresponding points. So you see, when you are joining the corresponding points, your point 1 is changed to the point 2 and point 2 is changed to point 3 because you have rotated the object at a twist angle of 90 degree or any other angle. Again, this option is not available inside the simple extrusion. This is only available in the uh, sweep command. By twist, I mean, let's say this point is 1. You see, let's say this point over here is 1. This one is 1 point. But over here, the 1 point will be this one. Why? And you can see the object is joined like this one. Why? Because we have rotated this object at 90 degree. When you rotate this object at 90 degree, this point will come over here, this will come over here, this will come over here. And then you have to join the corresponding points over here. I hope you are getting my point. So when you are rotating the object, you have to join the corresponding points when you rotate it. So basically you are getting a twisted object over here, which is clear from here that you can see that the object is being twisted. You can see this line is joined with this one. It must have joined with this one, but we have rotated this object. So ये point जो है ये इसके साथ join किया गया है, ये point इसके साथ किया है, इस तरह ये point इसके साथ, and that point is joined with this one. You can see over here that the point's rotation has played its role and it has rotated, twisted the object over here. You can apply twist and scale similarly, simultaneously. I mean that, let's say you want to, what's happened to this thing? Let's say, let me draw another rectangle over here, then you will see what does it mean. Let's say there is a small rectangle over here, and I want to convert this using the sweep command. Sweep, select object, okay. Let me apply twist angle, which is 90 degree. You can apply, give any, and let me give a scale as well. It is 1.5. Now select the object. You can see the object is twisted, and in the same time it has increased the end dimensions at a scale factor of 1.5 compared to this one. You can see this dimension is greater than this one. It is also twisted, and you can see over here this point has been brought to this one. It has been rotated. Okay, this point has brought to this one, and it has been rotated at a particular angle, which is 90 degree. So you can apply the twist angle, you can apply the scale factor very easily while using the um, sweep command. And this command is normally used to convert any object into any cross section into any particular profile. Normally, we use sweep command to create threads, 3D threads or 3D shafts with threads. You can create gears as well using the 3D commands. Sorry, not gears, screws, etc. Threads and screws, etc. can be created using 3D command. Let me do it using the helix command. Let's say we have helix command over here. This is the diameter and this is the end diameter. Okay, and let's say the length is 10. What happened to this thing? Okay, we have a helix over here, so we have drawn it. Okay, we have drawn. Let's see it how it look like. Okay, it's very small. So let me do it again. Helix. Okay, let me do it a small one diameter. Okay. Diameter is, let's say, 10. The end diameter is, let's say, again 10, and the height is the turns. Let me increase the turns. TU turns. Let's say bring it to 10, and height is, let's say, anywhere like this one. We have just created a 2D model, a sweep, a 2D sweep path, which is basically a helix path. Now we want, it is just like a spring. Now we want to convert, let's say, and we have, you can see we have drawn this in the top view. Now we need to bring it to the front view to draw a cross section. Otherwise, we will not be able to convert it using a sweep command. So let me draw a simple circle. You can even draw it at the end of this object. Okay. Now let's go to the isometric view and use the sweep command to convert this object into this path. So sweep, select object, okay, and then select path. It's taking some time. Let's see. We'll see when it is done. Okay. So you can see the object is swept along a helical path, and you can see we have got a spring, and the pitch and the each and everything of the spring is kept uniform throughout the length of the spring. So with the help of this, you can create springs, you can create um, threads or any such type of objects using the sweep command. And you can again increase or decrease the end diameter. You can give a twist as well using the sweep command. So this is one of the example with the help of which we can create different types of springs if you want to use the sweep command. Okay. Uh, Next to the sweep command is called revolve command, which is again a very simple command in 3D CAD, where we normally convert a 2D cross section into a cylindrical object. By cylindrical, I mean we are normally we have talked about the solids of revolution, so we are basically revolving the object around a particular path. Let's say I have this path over here, and I want to convert this path. Let's say I want to convert this path or revolve this path, this cross section. Let me make it close object. It must be close object if you want to convert it as a solid. Otherwise, it will be converted as a surface model. What is not doing is a boundary. It has been converted into solid object, a single entity. By revolve command, I mean we are revolving this object about a particular cross axis, just like we discussed in solids of revolutions. These are the solids of revolutions which are uniform throughout a particular axis, whether the angle is 360, 270, 180, any angle, but the object is uniform throughout that particular angular direction. So let me use a revolve. REV is the shortcut key for revolve. It is asking me select objects to revolve. Okay, I'm selecting this object. Then it is asking me select axis. So if you have any axis, let's say I'm selecting this axis, or instead I can select this axis, or I can select any axis, any 2 points as an axis. So let me select the object's endpoint, then select the um, and let's select this object. Let's say this is the start point and this is the end point. Now you can see you can rotate the object in to any angle. Let me change the view so that you people may clearly see that what's happening over here. Let's see, it's like this one. You can see you can rotate the object into any angle. You can give an angle over here. You can reverse the direction just by clicking the reverse. You will see you are just copying it. Okay, you are just rotating, changing the angle of rotation. You can bring it back to the initial position. Again, it is a start angle means from where you want to measure. Normally, it is measured from XY plane, which is zero angle. You can see over here. If I bring it to top view and then bring it over here, you will see what does the revolve mean. Select object, okay, and then select this path and this path. You can see it is angle is measured by default from the base angle. Bring it happen to this thing. It's not showing. Let me delete this thing. It was a very simple object over here so that it is clear to us. But you should keep in mind that this object should be closed, which you are converting as a solid object. So if you want to convert it as a solid object, okay, okay. Sorry, it has been converted. We don't want to convert it like this one. Okay, let's see what's happening over here. Uh, UCS and move. You can move the UCS to any point to just see the uh, what's happening with reference to XY plane. So revolve, select object, and then select axis of revolution. Let's say this is my axis of revolution. Now you can see from where it is measuring from its base angle x-axis. You can change this direction. If I give start angle to 0 to 90, it will measure from 90 angle. You can see compared to this one, it is measuring now from XZ plane. Okay, but before that, it was measuring from XZ. Now it is measuring from YZ plane. If I change it start angle to 0, it will again measure from the XZ plane. You can see over here. If I bring it to this one, then it will be more clear to you people. Select object, select path. Sorry, all, select object and select path. Path can be anywhere. I am selecting again and again. Let me revolve, select object, okay, then select path. Now you can see it is measuring from the XZ plane. But if you want to change the start angle, so this is basically 90 angle, it will measure from the YZ. And if you again want to change this, let's say make it 45, so it will measure from angle somewhere at 45 angle. It is making rotated this UCS accordingly. Okay, if we want to make it start angle 0, it will bring it to 0. Start angle 0, it will measure from the normal XY plane. And you can give any row angle of rotation. Let's say my angle of rotation is 270, so it will convert it into solid model is a 270 at a 270 degree. And this object similar, you can see the cross section is uniform along the angular path. This cross section is not changing because it is similar. You can see it is similar to this one, the start cross section. So it is just like a extrusion, but we are extruding it in an angular path, in a circular path over here. All the circular axially symmetric objects which can be converted into a revolve are always made using the mm, revolve command, in which the cross section is uniform and you just need to revolve it at around a particular cross section. With the help of this method, you can make rods, we can make um, mm, we can make nuts, heads, bolts. We can also make those things. We can also create with the help of this method different types of shorts with some features that can be easily created over here just by creating its one cross section. Even the engine cylinder piston can be created, or cylinder can be created just by applying the revolve command, by creating a one cross section and applying the revolve command over here. We can create a surface model and we can create a solid model. When your revolve option is You have the object selected is not the closed object, it will be converted as a surface model, otherwise it will be converted as a solid model. Let's see, we have an object over here and we have a path over here. Let's say this is a path and I want to convert it into revolve. So select object, sorry, select object, okay, and then it is asking me select path. Let's say I have done it like this one at a half, at a particular angle. You will see the object is surface model, not a solid object over here. Okay, so you should always keep in mind that the object that you are converting must be a closed and single entity, otherwise it will be converted as a surface model, not a solid model. You can see clearly over here. Again, if you don't want this hole inside this object, for example, you want cylindrical object which is not hollow from its side, so you just need to define the object close the revolution angle, the revolve axis exactly at the edge of the object. For example, let's see that I have an object over here like this one. We turn on the auto to get a piston. Let's say we have these are the grooves for the sleeve rings. Let's say, okay, let's say we want this thing, and we don't want this object to be hollow from inside. Okay, so what we do, we normally join this thing, okay, and we don't want a hole inside. If we need a hole, so we just need to define an object at an offset distance equal to the radius of the hole. So which will be making the diameter of the hole, and that will be inside hole. But if you don't want a hole, so what we can do, default, select the object that you want to convert, okay, and tag the edge of the object exactly. This is one of the simplest method. Let's say the angle is again 270. I don't want to convert it to 360 degree. You will see the difference now. You can see there is no hole inside as it is over here. Why? Because we have selected the object axis of revolution exactly at the edge of the object. So we have reduced and we have removed the hole from inside. If you want to create a hole, you have to take the axis at a distance equal to radius of the hole that you want to create. So it will automatically convert it at a particular um, diameter by just revolving the object. And you can see we have created just a cylindrical piston, half portion of the piston, quarter three by four portion, or a quarter portion is removed and three-quarter portion is over here. So we can see that we have we can convert any solids of revolution using the revolve command over here. Uh, Similar to the revolve command, we have some other commands with the help of which we can convert a cross section into the particular, sorry, we can convert a cross section into a particular objects. We are joining the cross section using some type of curves, and those cross sections are at elevations from each other. By elevation, I mean that let's say you have three-story buildings. You have three-story building. So you have on the ground floor, you have a rectangle. On the next floor, you have a circle. And the third floor, you have the pentagon, let's say. And you want to join these two different types of cross section using curved lines and convert it into a solid object. This can be done using the loft command. Any other command cannot do this. So we are bound to use the loft command for such type of objects. For doing this, we need the objects to be drawn at different elevation from either. If you remember while discussing the rectangle command, we talk about elevation in which we draw three different types of rectangles from each other at a particular height. So that can be used over here. Or we can just draw different types of objects very easily. So what does this mean? Let's do it. Let's draw a rectangle over here. Okay. To understand where is your object, so we will change. Initially we have drawn in the top view. Now we are changing into isometric view just to see what's happening over here. You can see this object is drawn in the XY plane because our XY plane is parallel to the top plane. Now let me move to the UCS. How to move the UCS? We will write UCS and move. M for move. We can move it to any point. Let me move it to this point, or even at the center point. You can see UCS has been moved to the center point. Now I want to draw another object, let's say a circle which is at an elevation at a height to this circle in the Z direction, at a height in Z direction from the XY plane. So what I will do, I will again write UCS. This is how we play with UCS. Enter and move, and I will write 0 comma 0 comma, let's say 30. You will see it will be moved from that initial position up to a height of 30, at a height of 30 degree. You will see it. Let me chair rotate this object. You will see the UCS has been moved at a distance of 30 degree. At a distance of 30 units, sorry, not degree. Okay. If I further want to move the UCS, I will write UCS um, and move and the 0 comma 0 comma, let's say again 30, let's say 40. I want to bring it, move it 40 more angle. Now when it is over here, so it is considering this point as a 0 point. You should keep in mind, you don't need to put at the right. If you put it, it will not affect the result, because when you are moving uses, you are basically moving your coordinates as well, and you are considering this coordinate at 0 0 now. So let me bring it back to this type, and let's draw a circle over here to see what's, sorry, circle over here. Let's do it. Let's say the circle is let's try to the center point over here. Okay, let's say this is a circle over here. You can observe it where it has been drawn. You can see it is drawn just above the object, not on the similar plane. Now let's move again the UCS and move, let's say 0 comma 0 comma, let's say 60. So it will be moved at a distance, because 0 comma 0 mean x is 0, y is 0, and 60 mean g is 60. Now again let's draw another object. Let's say we want to draw a pentagon, five-sided object. Let's say this is the center of the pentagon, and let's say it is inscribed in a circle, and let's say this is the shape of the pentagon. Let's see. Okay. Now you can see we have drawn three different objects at different elevation from each other, and we want to join these objects with certain types of lines to convert this into a solid object, whether it is hollow or solid, but we want to convert it into a 3D object. So for this we will use loft command, where we join the different cross sections at lofting order. So it is asking me select cross sections in lofting order, and you should keep in mind that this lofting order is very important in selecting the objects. I will show you the difference. Before this, let me take a copy of this object to see the difference among different options over here. Let's see. I'm just taking few copies from this object. Okay, so let's do the middle one, then we will talk about the others as well. So let's just do the simple loft command. Loft, we are selecting this object, then this object, and this object in the lofting order, and we are not selecting any other command. We have guides, paths, cross sections only. So we are just using the cross section only. We are just converting these cross sections into the particular solid object. If I say okay, so you can see this cross section has been joined using the curved lines, and the object has been converted into a 3D model. And you can see it is not necessary that the start cross section and the end cross section must be same, as is the case in the sweep command or in the extrusion command. Over here you can join any cross section with any other cross section, but the cross sections must be at an elevation. This is the important thing for this type of command. Okay. Just look at the difference between the lofting order, changing the lofting order. If I selected this object, then this object, and then this object. Let me do it again with the different lofting order. Let's say I'm selecting this object first, this second, and this one third. Okay, and okay, no other option over here. Okay, selecting entities are not valid. There might be some problem with this. Let me increase this diameter. Maybe it may help us. Okay, let's do it again. Maybe it help us. Loft, select this object, then this object, and then this object. Okay, yeah, it's not doing it again. There again, it cannot do always all the objects to be converted. There might be some limitations, and that limitation is when your basic cross section is deformed so much that it is not look like that basic features, it will be not converted. For example, if you are converting, selecting the objects in such a pattern, in such a order that this circle or this pentagon is changing its shapes from pentagon to some other shape which is not a pentagon. Let's say it is changing to a circle or it is changing to a rectangle due to a distortion of the shape, so it will not do it. This is the one of the uh, feature, one of the limitation, that it cannot always do follow the same uh, all sweep. Okay, it has done it. Okay, we have just changed the sweep order, and you can see the object over here. Initially we just selected this object, this and this, but now we have changed. Select we have in this object we have selected this object first, the pentagon second, and the circle in the last time, and you can see the difference. The object is converted into a solid object, but it is not like this one because we have changed the lofting order. So the lofting order does matter, and it changed the object according to that order. Okay, if I change again the lofting order to some other value, it will give you another object like this one. Let me do it over here. Let's start with LOFT, loft. Lofting order, I mean I'm selecting this object, then selecting this object, and then selecting this circle. And okay, no other option, guides, paths. We are just using the cross sections method. You will see the object is converted, but the shape is completely different from this one and this one as well, because we have used another path for this object to be used for the conversion of these objects. You can see over here. Okay. If you want to free rotate, so you can see it over here how it will look like. So this is how we convert any cross section or any different cross sections located at an elevation from each other into 3D solid objects over here. So this is how we convert the cross sections at an elevation and using the loft command. We can also use a path command over here as well. For that, let's say we have drawn all these objects in the top view, so I will select side view to draw a path over here, just like the extrusion along a path. And let me select a spline. Normally it use the spline for the path, and the reason is that it normally, let me do it, let's say uh, SPL. Okay, start point is the end point. You can see, sorry, start point, you can see I have drawn an object from this point up to this point. So we have 2 points over here. So it will also follow the path. It will extrude it like this one using the loft command when we select this object as a path for the loft. So let's do it how it is doing it. Let me change the object. Let's say I want to use loft. I will select the objects in the lofting order. Okay, then I will select the path option over here, a path profile. Okay, it is not valid. Sometimes the profile, when the profile is not valid, it will never do it over here. So let me change what is the criteria for profile over here. Let's say line. I told you that when it is deforming the objects so that it is not remaining the original shape, so it will never do it. So let's try it again that whether it is doing or not. This object, this object, and this object. Okay. Select path. Okay, it is not doing it again. There might be some problem and the cross section is not informed. Let me delete this thing and see what it is doing it with this object right now. Select this object and this object, okay, and select path. I want to convert it along this path. These are not valid. Okay, these are not valid over here. We can do it with some other example like this one. Let me draw an object over here. Let's say in the top view. Let me take this as an example. Okay. Then change into the front view and draw an object like this one. Okay. And draw a rectangle over here. Let's say I'm drawing it in the side view instead of front view. Let's do it in the side view. Okay. Rectangle. Let's say we have a rectangle like this one, and I want to bring it to front view and want to join these objects with a path. Okay, so SPL is a short line. Okay, sorry, not doing drawing a simple line. We can do it with a polyline, and we can convert it. Normally, the polyline is happening over here. Start point, and this is the it's happening. We have selected our which plane over here. We have selected our uh, front plane, okay, and we want to draw it. Why it's not doing when you are in front plane, so it must do it. Um, Polyline, okay, an object like this one, let's say. It's not necessary to be joined with that one. And we can convert this polyline into um, this is the option. We can convert the polyline into set constraint. No, 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 no. We have an option over here with the help of which we can convert this polyline into curve fitting. I don't know why it's not working over here. Okay, let me change this one to spline. This is a spline for this conversion. Now you can see the objects are drawn in different plane and this thing is drawn in different plane. You can move this object from here as well. Move, select object, and move it up to this point. Now you will see it more clearly that the object has been moved. Now you can convert this object using a loft command, and this cross section can be any other cross section. It is not necessary to be similar, just like in other sweep loft command. But over here we are just defining a path along which we want to convert this object. Okay, so over here we want to define a path, and for that we have defined two cross sections and a path. So I will use again loft command. Select objects in the lofting order, okay, and then select path. If you select this path, it must convert the object into this path. This is again just like a sweep or a extrusion along a path, but over here we have the option, we can change the cross section from similar to different one, which means that this cross section can be different from this one while using while doing this using a loft command. We can also do it using the guiding curves. Like let me draw a line from this point and another spline, let's say from this point. Now we have these guiding lines. These are the extreme lines which is defining the shape of the object. I can do it using a loft command using by defining the guidelines to select the objects in lofting order, this object and then this object, and press enter. Now select guides, GUIDS, G for guides. So guide profile this one and guide profile this one. These are the two profiles that will define the end shape of the object over here. You can see. So we have just defined the guide profile, this one, and just looking into the cross sections, it has changed. It has changed the shape of the object accordingly. So that all these all depend upon the cross sections, the method that you want to convert, join these cross sections into 3D model or 3D solids or surface using the loft commands. All these things depend upon the lofting order and the pattern that you want to follow over here. So this is how we can convert, and these are the basic solid commands over here. These are very basic solid commands like extrusion, uh, revolve, sweep, loft. These are the most commonly used solid commands with the help of which we can convert any solid of cross section into a particular types of solid. And you can see each and every one has different features. Some features are common like extrusion or sweep or loft along a path, but rest are different. In extrusion, we are bound to just convert a simple extrusion, but when you need to have some more features like twisted angle or rotated objects, then you can use the loft sweep command and you can use the loft command as well. We can also use a twist angle in the loft command, simple loft command. Let me check whether it is working over here or not. Okay, select this object, and this object, and let's see the setting, what we have option in the setting. Draft angle not required. Okay, well, it is not available over here. It is not available. The difference between smooth fit is basically it is adjusting the curves, but when you change it to rule, you will see the difference. It is very rough type. This is a smooth curve, this is very rough type. So it is joining the corresponding point straightly with the other point. It is not a simple one. Again, if we use a loft command and select the, we had, we were having a twist angle over here, but I don't know why it's not present in this CAD. So that's why this is smooth. If you change it to rough, you will see the shape. If you bring it back to the smooth, you can do it. You can add draft angle. By draft angle, when it is 90, so it means that the object which is just in coming out of the this angle, the object will be always start of the object will be perpendicular to the cross section. Similarly over here, it is making perpendicular this section, then coming out perpendicular. Over here, these are very small, which are not clear. But when the draft angle is 92, it means that the angle between this line joining this cross section is 90 degrees. This is telling us about the draft angle. And you can see the difference between these two objects over here. You can see these are a bit more, this is drawn with the curve. Let me move this object from this point to over here. You can see this is drawn a bit more smooth as compared to this one. You can see why, because we have added the draft angle to this object which is not present in this object over here. Okay, so this is how do we convert the solid object into 3D using the loft command over here. So with this, we are done with the basic 3D modeling. 3D modeling like extrusion, sweep. mm, we can use the loft command or we can use the revolve command for the conversion of any cross section depending upon the object, whether it is a solid to be revolved or it is solid to be converted or it is solid to be loft. So that is depending upon the shape and the dimensions available and the cross sections available. If you have a similar cross section, you can use soft sweep and you can use extrusion. But when the cross section is changing from one to another, then you must use the loft command. And normally, most of the curly shape bottles, etc., are made using the loft command. You can see that sometimes the bottle shape is rectangular and in upper portion it is sometimes elliptical and in the most upper portion which is the neck is normally circular. So we just define the different shapes and height between the shapes and just apply the loft count. It automatically convert that object into a simple object, a simple bottle. Okay. With this is the end of our lecture. If you have any question, you can ask me or you can ask me in the stream. I will upload the recorded lecture and we will continue uh, or we will try to cover or finish the 3D modeling in the next class, inshallah, uh, where we will talk about the solid editing commands like how to add, how to remove a face, how to change the color of a face, and how to play with the edge colors, etc. Then we will also talk about how what are the solid composites, how we can join, how can we trim, how can we subtract, how can we intersect two different types of solid objects, how we can make align two solid objects to each other. We will also talk about 3D mirror, how do we 3D mirror object, what is how we array 3D array the objects, how we can rotate the 3D object, how we can move in 3D an object, and also we will also talk about shell command and a very important other command which is called imprint, where we can imprint a particular 2D drawing on the surface of a 3D object and make it a part of that object or that surface. So we will talk about it and then we will talk about some rendering and other commands in the preceding in the next classes, inshallah. So I hope all these things are clear to you people. Still, if you have any question or you can confusion, we will discuss it in the class in the next week, inshallah. Thank you very much. Allah Hafiz.
Sir,
Yes, please.
sir, general question we are recording of.
Okay.